So on this first problem, I drew out the triangle and they want us to find area. And when we find area, we should be having side, angle, side. We should have the two sides that form this angle. So the two sides with the angle in between. And so in this case, this would end up being little b, this would end up being little a, and this is angle C. And so I would do 1/2 a times b times sine of C, because that's what I have, little a, little b, and angle C. And so I'm going to have 1/2 times 7 times 5 times sine of 46 degrees, and I'm going to put that into my calculator. And when I put that into my calculator, I end up with 12.59 when I round, 12.59. So I will enter in 12.59 for my answer. Okay, next one. So on this one, we're asked to find little c. You can see these ones are pairs. We have the angle on the side opposite here. We have the angle on the side opposite. Since we have the angle on the side opposite for one, we can use law of sines. So we're going to use law of sines to find little c. So I set up sine of 70 over 15 equals sine of 45 over c, cross multiplied, divided by sine of 70. And again, this is a little c. So I'm going to put this in my calculator. And when I put that in my calculator, I end up getting 11.29 as my answer, 11.29. And when I go put it over here, okay, typing in 11.29. Okay, this next problem, we are asked if this would be an ambiguous case. And so ambiguous case is when you have side-side angle. So on this one, when we're looking at this, we've got side-side angle, which is the ambiguous case. So this would be, when we choose our choice, yes, this is an example of the ambiguous case. Now, maybe we have no triangle, maybe we have one triangle, maybe we have two. Okay, we'll see that on the next one. So here they want us to calculate A, okay? And so we're going to try to find the first value for A. Now looking at this, I have this pair of opposites, and I have this one that I'm going to find. So when I have a pair, an opposite angle and the side opposite, then we're going to use law of sines. So I set up sine of 80 over 7 is equal to sine of A over 5, cross multiplied. Got sine of A is equal to 5 sine 80 over 7. I want angle A, so I have to do sine inverse. And when I put that in my calculator, I end up with 44.70 as my possible angle. So I am going to put that here. So 44.70. Now the next question is asking what is our second possibility for that angle, okay? So what I need to do is I need to take this angle and go 180 minus it to find my other possibility. And then I need to check it to make sure it makes sense for this triangle. So to find my other A, I take this original A, I go 180 minus that to find the other possible A. So the other possible A is 135.3 degrees. Okay, so 135.3. So that's what I'm going to enter over here. 135.3. Oops. Okay. Now when I go to the next one, it says, does the second possibility work for angle, for the second possibility for A? Is there a second triangle possible? So here, what I did was I took the 80 degrees, which is in the triangle. I took my new A, which is 135.3, and when I added these together, I am going to get more than 180. And I can't have that happen because I'm only dealing with two angles, and I'm already more than 180 in a triangle. So the answer to this is no, it does not work. There is no second triangle. So we know this is angle B, they gave us B. I called this A and C just so that I can just use those letters when I do a formula. So across from angle B is little b, so these match. So again on this, I call this A, B, and C. I just added those letters. So this is, whoops, mistake here. This should be 10. Okay, so this is B, this is little b. I'm calling this A and little a. And then this I'm just calling C, and this I'm going to call little c. Okay, so this is my X, but I'm going to have it be my little c. And so this is what we're going to find. So when you're looking at this, you want to see, do you have any pairs? So you see the blue, I don't know the angle. Here, I don't know the angle. Here, I know the angle, but I don't know the side. So I have no pairs. So I am going to use law of cosine. And I'm trying to find this side X, which I'm going to call little c. So I'm going to use the c squared equal formula for law of cosine. So I'm going to use the c squared is equal to a squared plus b squared minus 2ab times cosine of angle c. And so then I put in my values for my a squared, my b squared, my minus 2ab times cosine of angle c. And then since it's c squared and I want just c, I'm going to take the square root. Okay, and I'm going to put that into my calculator to get my answer. And so when I put that into my calculator, I end up with 11.46 as my answer for side C, little c, which is our X. So for this, again, here c squared is equal to a squared plus b squared minus 2ab times cosine c, using that formula, plugged in my values. Okay, for a squared b squared minus 2ab cosine c, put it into my calculator, and when I put it into my calculator, I got 11.46 for little c. Okay, so 11.46 is that answer. So on this one, it doesn't appear like we have a pair at first. So A and then the side opposite it, I don't know the angle. Here, I know the angle B, but I don't know the side opposite it. And C and the side opposite this, okay? And for this one, they had here capital B, but I think they want the little b here because we already know capital B. So I'm going to change this to little b. Okay, we're going to find little b. So again, I don't know this. Okay, missing one pair here, missing a pair here, missing a pair here. So at first it doesn't look like I have any pair, but if you take a look at this, you do have two angles. And if you have two angles in a triangle, you can find the third angle. So I can find angle A by just doing the math, 180 minus 82 minus 24, and I end up with 74 degrees. So I know that this is 74 degrees. So now I actually know a pair. And so now I can use law of sines. So let me write out that formula. So I did sine of 74 over 11 equals sine of 24 over b, cross multiplied, and then I got b equal 11 sine 24 over sine 74. When I put that in my calculator, I get that b is equal to 4.65. And so that's what I'm going to put in here, 4.65. So on this one was little a, angle A though, is what they are asking us to find. So I wrote big A here, just so we understand we're finding the angle. I just call this one B and C. And you'll notice I don't have the angle and the side. I don't have an angle on the side. I don't have an angle on the side. So I don't have any pairs. So that means I'm going to use not law of sines. I'm going to use law of cosine. And for this problem, they want us to find angle A. Okay. So that means I'm going to use the cosine of angle A formula. So I use cosine A is equal to b squared plus c squared minus a squared over 2 times b times c. Okay, and then since I need to find actual angle A, I need to do cosine inverse of b squared plus c squared minus a squared all over 2bc. And then I just substituted in the values, 19 squared plus 9 squared minus 16 squared over 2 times 19 times 9. I put it into my calculator and I ended up with a 57.05. So I'm going to enter that in, 57.05 as my answer. So on number 7, when we have a single logarithm on one side, no log on the other side, we want to get this to be a single log, which it is. Then we're going to rewrite it in exponential form. So I'm going to take my base, which is 2, to my power, which is 3, equal x minus 7, and then solve. So 2 to the third is 8 equal x minus 7. I'm going to add 7 to both sides, and I get 15 is equal to x. Now, you always want to check and make sure that this, when I put in 15, does not either give me 0 or a negative, because I cannot take log of 0 or a negative, but it doesn't. So my answer is 15. So I'll put that in, 15, as my answer. So on this one's different than the last one because I do have logs on both sides. I also have over here where I have 2 logs, and I want to make this into a single logarithm. And so when you have a plus, you're going to take what you're taking the log of here, x minus 5, times what you're taking the log of here. So I'm going to have log base 6 of, and when I do that math and I take x minus 5 times x plus 7, I'm going to get x squared plus 2x minus 35. And then that's going to equal log base 6 of 20. And when we get a single log on one side equal a single log on the other side, whatever you're taking the log of on both sides, so this and this will be set equal. So I'm going to have x squared plus 2x minus 35 is equal to 20, and I'm going to solve this quadratic. So I'm going to get x squared plus 2x minus 55 is equal to 0. And then I'm going to solve this equation. So for this particular one, this is not going to be factorable because there's nothing that is going to multiply to a negative 55 and add to a 2. So I'm going to do completing the square. So I'm going to have x squared plus 2x. I'm going to take my 55 over here. And then I need to figure out what I'm adding. So to make this into a perfect square, half of 2 is 1, and 1 squared is 1. So I'm going to add 1 here and here. And then I'm going to get x plus 1 squared is equal to 56. I'm going to solve this. So I'm going to have x plus 1 equals plus or minus root 56. And then I'm going to minus 1 from both sides. And so I'm going to get a -1 plus or minus root 56. And let's see what I get as a decimal here. So when I put that in my calculator, -1 plus the square root of 56 is going to give me a 6 point, let's say 48. And if I put it with the minus, that's going to give me a -8.48. Now, negative. Now, remember, when you take log of something, you can only take log of something that's positive. So when let me get back to my original problem, and I put in a positive 6.48, that's going to make both of these positive, so that's fine. When I put in this negative, it's going to make both of these negative, but even if it makes one negative, that's not going to be a solution. So this one's going to be a no. This is going to be my answer. So I'm going to put in 6.48. Okay, so the next one, this one we have two logarithms on one side and no log on the other side. So I need to get a single log on the left. So again, on this one, we want to make this into a single logarithm. So since it's a minus, that means these two things will be dividing. So I'm going to get log base 3 of x over x plus 3 equals 2. And then once I get it to be a single log on one side and we don't have a log on the other side, we rewrite it in exponential form. So I'm going to go 3 squared. 3 to the second is equal to x over x plus 3. That is going to give me 9 is equal to x over x plus 3. I'm going to put this 9 over 1 and cross multiply. So I'm going to get x equal, when I multiply this together, 9x plus 27. I'm going to minus 9x, so I'm going to get a -8x is equal to 27. So x is equal to -27 over 8. And if I put that into our calculator, so -27 divided by 8, I get a -3.375 as my answer. Now, when I put that into the original problem, that's going to make this negative and this negative. So this actually is not going to be an answer. Now on this one, they didn't give you an option to say that because they did ask for a number solution. So there is really no solution. I'm just going to put in the -3.375. That's what we would have gotten, but again, when I put that in, it's going to be no solution. On this one, we have to enter a number in, but really this would be no solution on a test. Okay, next question. So in this situation, you have logs on both sides. Now the problem is, I can't just say x minus 11 equal 2 because there's a 3 here. So this 3 is really going to become the exponent of this 2. So this is really going to be log base 3 of x minus 11 equals log base 3 of 2 to the third, okay? And 2 to the third is 8. So again, this is going to be log base 3 of x minus 11 equals log base 3 of 8. I now can set these equal to each other because both sides are log. So I get x minus 11 equals 8. So x is equal to 19. And then you want to make sure when you put into the original, it doesn't give me 0 or negative. So that is our answer. So I'm going to come here and put in 19. So on number 11, this is one that's in exponential form. So on a problem like this, when it's an exponential form, your very first step is to get your base to a power by itself. So I want to get rid of this 9. So I'm going to divide this side by 9, and I'm going to divide this side by 9. And 1, 2, 0 divided by 9 is not a nice number, so I'm actually just going to leave that here for right now, and just we're going to put it in at the very end. So I get 1200 over 9 is equal to 7.3 to the power x. And so now when I have a situation where I cannot make the bases be the same, and I have to solve for the exponent, I'm going to log both sides. So I'm going to take the log of this side and take the log of this side. So I'm going to be taking the log of 1200 over 9 and 7.3 to the power x. Now, this exponent is going to move in front, okay? So now I'm going to have log of 1200 over 9 is equal to x log of 7.3. And then I'm going to take this log 7.3 and divide both sides. So I'm going to have log of 1200 over 9 equals log of 7.3 to give me my x. And when I put that into my calculator, log of 1200 divided by 9 over log of 7.3, I end up with 2.46. So x equals 2.46 about, and so that's my answer that I'm going to come put in over here. So about 2.46. So on this next one, we are expanding, okay? So on this one, let me first write it. So on this, just remember that ln, the natural log, is really log base e of whatever, okay? So that's all that ln means. And in this case, that doesn't even matter. We don't need to write log base e, but just in case you see a problem where you do have an ln and you have to rewrite it, understand that it's really e is your base. So it's really log base e of this, okay? So to expand this, I'm going to have a log, or in this case, natural log, for 5, for a, for b, and for c squared. So anything on top is going to be adding, anything on bottom is going to be a minus. So I'm going to have ln of 5 plus ln of a, let's scooch out a little, minus ln of b, minus, and then the c squared, the 2 comes in front, so 2 ln of c. And that's going to be the answer that I'm going to write here. And this is one that you can actually write using the pens here. So ln of 5 plus ln of a minus ln of b minus 2 ln of c. And the last one. So on this last one, so this is all going to be log base 2. I'm going to have 1 for n. Now this right here is really a 3 to the 1/2. Let me make this a little thicker. A 3 to the 1/6, sorry, 3 to the 1/6, because it's the 6th root. So I'm going to have 1 for n, 1 for 3, 1 for 5, and 1 for m. Okay, so for this, I'm going to have log, a little bigger than that, log base, let's see, I'll write it over here. So I have log base 2, actually I'm going to have a 2 in front of it because of the exponent of 2. So I'm going to have 2 log base 2 of n plus, again, that's a 1/6. So 1/6 log base 2 of 3 minus log base 2 of 5 minus log base 2 of m. And that's going to be your answer. So make sure you practice these problems, the ones we had on the last PowerPoint or Google slide, the 4 D-Days that we've had, and make sure that you're ready for the test, which is going to be tomorrow.